number 66. Find the distance along an arc on the surface of Earth that subtends a central angle of 7 minutes. They give us some conversion that 1 minute is equal to 1/60th of a degree. The radius of Earth is going to be 3,960 miles. Our first thing is sketch a picture. So draw a circle, all right? And pretend that that represents the circumference of Earth there, okay, the black line. Now here is going to be the radius. They tell us the length. It's going to be 3,960 miles. Cool. Now what they want to do is they want us to find the arc length, basically, right? And they tell us that the angle that is created basically from this central angle is going to be, I'm going to exaggerate it. This is way not to scale, but this angle in here, okay, it's going to be 7 minutes. Now you're like, what? Minutes? I thought that was time. That's also a degree measure? Well, or I should say it's an angular measure. And yes, it is an angular measure, but we don't really like to work with that. We like to work with degrees. So what we're going to do is we're going to do a little conversion, okay? I want to figure out how many degrees are in 7 minutes. So they give me a relationship here, right? They say 1 minute is going to be equal to 1/60th of a degree. What that means then is that then proportionally speaking, 7 minutes must then also be equal to x degrees, right? That's the problem. So basically what we have here is we have a nice little proportion, okay? So just put one equal sign in here. Notice the units, the minutes, and the minutes will cancel, so just get rid of them. That should happen, okay? Also over here too, I mean, the units will cancel, right? You can leave them in because you know your x is going to be in degrees, but you can just get rid of them to simplify the calculation. Now take a look at what we got. All right, we have a simple little fraction here, or set of fractions, right? Well, we have complex fractions since we have a fraction within a fraction. It's like the inception of fractions. Great movie, by the way. Anyway, so what we want to do is we want to solve for x. So we want to cross multiply x on out. Now you're allowed to move x diagonally across an equal sign like this. You're allowed to move any variable diagonally, never horizontally, just diagonally, okay? So you move the x diagonally over there, it's going to be 1 times x. You move the 7 on over here, it's going to be 1/60th times 7. And there you go. That's what x is, because 1 times x is just x, so just get rid of the 1. And there you go. You can plug that into the calculator if you want, or you can leave it in terms of the exact answer. It really doesn't matter, but you can do 7 then divided by 60. And we get a value of about 0.116 repeating, okay? Now remember, that's going to be in terms of now degrees. So this is now your degree measure. In other words, the 7 minutes here is no longer needed because now we have 116.116 degrees. We know the measurement in terms of degrees, okay? I put a little circle there for degree. Now what they want us to do is they want us to calculate the arc length. In other words, this length that I'm outlining right here, okay? That's what they want us to calculate, that arc length. Let's see if I can make that a little neater, match it up to the circle kind of perfectly. There you go, okay? That's what we want to find. We want to find the arc length. Now, how do we do that? Well, we can kind of do another proportion, or we can create a new formula for ourselves. Depends on how you want to look at it. Let me ask you a question. What's the circumference of a circle? What's the formula? Right. It's going to be 2 pi times r. You might have said pi d, which is totally fine. All right, but in this case, I'm going to use the 2 pi r version. Reason being is because they already gave me the radius. Now, when you use this formula, the circumference that you're calculating is the entire length, okay, of the outermost edge of that circle that's created by this particular radius you're talking about. But you don't want to know the entire thing. You only want to know a little fraction of it, right? So, wait a minute. If you know that there are 360 degrees, right, in an entire circle, and you're only dealing with this little fraction, then actually you know what fraction of the entire circle you're dealing with, okay? So what you can do now in this calculation, there's a whole bunch of ways to set it up, but you're basically going to multiply this by your degree measure divided then by 360. Okay? Now, why does this work out this way? Well, imagine if you plugged in 360 for the actual degree measurement. Imagine this angle over here that you created, went all the way around. Well, that's kind of cool. I didn't think it would have, yeah, well, I didn't really want it to do that, but what are you going to do? Imagine though that we wanted to measure the entire length. So we would have been talking about a 360-degree angle, and 360 over 360 is just going to be 1. Oh, wait a minute, that simplifies down to just the circumference. Oh, wait a minute, that's what we talked about before. The circumference is that whole outer edge. So whatever imagine you're talking about 180 degrees. So you plug in 180 over here. This works out to be now 0.5, a half. But that makes sense because 180 degrees is half the circle. So it's half the circumference. Cool. Now, start plugging the numbers. So 2 pi times the radius is going to be 3,960. It's going to be in terms of miles, so just keep that in mind. Multiplied now by the degrees of 0.116 repeating, all divided by then the 360. Okay? So take out your calculator, plug it in. If you want the exact answer, leave it in terms of pi. You calculate everything except the pi. Don't throw it in the calculation, just throw it in at the end, meaning you get your number and then just throw pi in at the end and you're done. All right, I'm going to throw everything into the calculator and probably round. So 2 times now second pi, all right, multiplied then by the 3,960, multiplied then by the answer. Now I want to take this exact answer. I don't want to round over here. I want to take the exact answer in the calculator. So you can just hit second answer now. And that pulls the answer, your prior answer, down on into the calculation, okay? Then divide it then by the 360. And voila. So, and I should have also, by the way, I should have also changed this now. This really, I shouldn't have a C here anymore because the formula is not a circumference formula. It is now an arc length formula. So you can just call it arc, okay? It's an arc length because it's not necessarily the circumference. The circumference is the entire length of one revolution, basically, okay? So the answer is going to be 8.06 if you round. And what's the unit? Well, it's in terms of miles. That was the distance of the radius. And the units over here will cancel. They're both degrees, so who cares? Guys, that's it. Okay, that's the length. Thanks so much for watching. If this helped you out at all, give us a hand. Like and subscribe. Tell your classmates. That's all you have to do. All right? And we appreciate it so much. It gives us also a lot of motivation to keep going. Sometimes it gets a little difficult, as you can hear in my voice. Take care.